Hello, I'm Noah Shalabi. I'm with the Neuroengineering and Pain Research Lab at the University of Connecticut, under the supervision of Dr. Bin Feng. In this video, I'd like to give you a quick introduction to pain. So what is pain? We've all probably experienced pain at some point or another in our lives, so we can describe it as a severe discomfort as a result of injury, disease, or even a bad emotional experience. Being in pain is unpleasant. So why does it happen? Pain is actually very important. It's a very important sensation that can protect us from harm, and we cannot do without it. For example, if we touch something hot because it's painful, we quickly move away. The pain served as a warning that something bad has happened or is going to happen, and you need to move away. Afterwards, you'll be careful not to repeat the same mistake, so it teaches us to avoid similar experiences in the future. Also, when you've hurt some part of your body, you protect that part and rest it to avoid the pain, and that helps it heal better and faster. So we all feel pain. Know what it is, but what exactly happens? How do we feel the pain? It all lies in noxious stimuli and nociception. So what do these words mean? Well, noxious stimuli are the things that happen to you that made you feel pain. And that could be mechanical, such as dropping something on your foot, or thermal, like touching a hot pan on the stove, or chemical, like eating a chili pepper. Nociception is your body translating this external thing that has happened to you into signals your body can understand and react to. Let's say, for example, you drop something on your foot. The signal will travel from your foot to the spinal cord, and the spinal cord will send the signal to the brain. The brain processes the information it got and decides whether it was painful or maybe not that bad. So it's only when the signal reaches the brain do you feel the pain. All pain perception happens in the brain. So how does the noxious signals travel? Through what is known as the nociceptive pain pathway. We have nerve cells all over our body connecting every part of us to the spinal cord and brain. And when the noxious stimuli activate the end of one of these nerves, the signal travels through the nerves to the dorsal root ganglion, DRG for short. The DRG then sends it to the spinal cord, and the spinal cord sends it to the brain, through what we call the ascending pain pathway. The brain processes the information it gets, assesses the situation, and sends the decision down to the spinal cord in what is known as the descending modulation. We'll talk more about that in a minute. But first, I want to talk about the two most important types of nerves that carry the pain signal from the site of the stimulus to the spinal cord. The first is called the A delta fibers. These are nerve fibers wrapped around with layers of fat, like the fiber here on the right. This layer of fat acts like the plastic insulation in electric cables, and it's very useful because it makes the signals travel very quickly to transmit the initial feeling of pain, like the early warning signal. The other kind of fiber, the C fiber, doesn't have that fatty layer, making the conduction speed much slower, but it's responsible for transmitting the intensity of the pain, how painful the stimulus is, and can become sensitized in chronic pain, which we will talk about in detail later. Now, let's go back to the descending pain modulation we mentioned. We said the brain processes the information it gets and then responds. But how does it respond? It either maintains the same level of pain you felt, or interestingly, it can sometimes lessen the pain. For example, we hear sometimes of people who get injured in battle or in sports competition but keep going and do not feel the intensity of their injury until later. The brain decides that the person should not be distracted by pain at that moment, so it reduces the pain. In fact, our previous experiences and memories and emotions play a big part in how we perceive pain. For instance, if you were previously injured in a similar situation, you could be on edge and as a result have an increased sensation of pain, while if you're in a safe, familiar situation or environment, you may have a reduced sensation of pain. This is all because pain is a complex, subjective experience, and because the brain is a complicated organ. There is no one area in the brain that's in charge of pain. Pain was found to activate many different brain regions where already there was so much going on. Each individual's pain perception was found to be affected by their biology, their genetics, their emotional state, and their past experiences. Here are two very interesting experiments that show the dissociation of nociception and pain. How sometimes you can feel pain even if there is no obvious cause for it. We're not physically hurt in any way. This is a way to show the big part perception and the brain can sometimes play in the experience of pain. The first experiment on the left is the thermal grill illusion. The illusion is created by alternating warm and cool bars, a warm bar followed by a cool bar followed by a warm bar, and so on. Now, the warm bars are only around 40 degrees Celsius, which is 104 degrees Fahrenheit, and the cool bars are only around 20 degrees Celsius, or 68 degrees Fahrenheit. So you can easily place your hand on the bars individually, and you won't feel any discomfort. But if you place your hand on this grill as shown in the photo, you experience an uncomfortable burning sensation. It seems that the feeling of both coolness and warmness tricks the brain into feeling that the surface is burning, when in fact your hands are perfectly safe. Another illusion is the rubber hand illusion. A volunteer sits with one hand out of view and a rubber hand placed in view in its place. When the rubber hand and the hand out of view are brushed softly in the same way at the same time, the volunteers report feeling that the rubber hand is in fact their own. And if you threaten the rubber hand with a knife, for example, they feel nervous and anxious and want to pull their hand away, even though their actual hand is not in danger, only the rubber hand. The last thing I want to talk to you about today is the two different kinds of pain, acute and chronic pain. Acute pain is the one that first comes to mind when we say pain. It's the good kind that we talked about in the beginning that can protect us and help us heal. It's usually sharp, sudden, and as a result of tissue injury. It could last from a few seconds up to a couple of months and gradually lessens as the tissue heals. Chronic pain, on the other hand, is ongoing and long-lasting, even after the original injury or illness has healed, and there is no clear cause for the pain. It's a very serious condition that has a big problem in our society, and we will address it in more detail in the next video. Thank you so much for listening, and I hope you learned something today.